This is an example of how to solve a mole mass stoichiometry problem. So first you're going to look at your equation and make sure it's balanced. We see coefficients, so we know it is. Next you're going to rewrite the problem as a math problem. So you know we have 625 grams of iron oxide. We want to know how many moles of hydrogen are going to be produced at the same time. So math problem is 625 grams Fe3O4 is equal to how many moles hydrogen. And remember, hydrogen's a diatomic, so it's H2. Next, we're going to look at our balanced equation, and we're going to look for the mole-mole ratio we're going to be working with, and we're working with hydrogen to iron oxide. So we're going to be plugging in a 4:1 mole-mole ratio. Next, we're going to set up our map because this is actually a gram to mole stoichiometry problem, so we need to use the map. So hopefully you've memorized it. Mass, mole, mass, and known, unknown. I'm going to go ahead and mark which is my known and which is my unknown. So Fe3O4 is my known because I know that I have 625 grams of it. H2 is my unknown because I want to find out how many moles of it are going to be produced. So I'm going to mark my map with my known. So I have grams of known, that's mass of known right here. And I've got moles of unknown, which is right here. So when I solve this problem, I'm going to be making a three-step grid. So let's go ahead and make a grid. So I'm going to do that. And then I'm going to follow exactly what the map says and plug these numbers in. So in the first spot, I'm going to plug in the mass of my known, and I happen to have that. So I'm going to put 625 grams Fe3O4. Next says to put in moles of known, so I'm going to write moles because it says to write moles. And known, I'm going to look for my known, and that's Fe3O4. So Fe3O4. Last box says to put in moles of unknown, so I'm going to write moles of my unknown. The unknown is H2. Okay. Now I'm going to fill in the bottom just by setting up my units to cancel. Always do this. So grams Fe3O4 and moles Fe3O4. Okay. Now I'm going to look at my ratios. So the first ratio I have is my mole to gram ratio. And whenever I have a mole to gram ratio, the moles is always going to be 1, and the grams is always going to be what we add up for the molar mass, which is 3 irons and 4 oxygens. That all adds up to 231.55 grams. Next, I'm going to look at my ratio here, and that's a mole to mole ratio. Mole to mole ratio is always from the balanced equation. I circled that earlier. So it's 4:1 ratio, 4 hydrogens for every 1 iron oxide. And then we're going to go ahead and solve. So 625 times 1 times 4, all divided by 231.55. And you should get, when I round, 10.80 moles of hydrogen. And that's how you solve this problem.